I built an regression model that basically takes what I eat and what I do for the last week and output how much weight did I lose. And I trained it, I tested it, and the results were amazing. So I just jumped out of the bed, I measured myself this morning and see was it really accurate with real life data that it's never seen before. And wow, it just wonderfully worked. This is the data I took this morning. I weighed 123 kilograms. Last week I weighed 123.9 and it predicted that I'll lose 0.9 kilogram. How fucking amazing is that? Okay, so let's wind back a bit. Hello everyone, my name is Bing and I'm an electrical engineer. But I don't only do electrical engineer stuff, I do a bunch of other stuff as well, like this, like machine learning, AI, cinematography, and whatever is fun, I'm in. And if you haven't figured by now, by just looking at the video, I'm overweight. But for the past 3 months, I've been on this weight loss journey in which I've lost a moderate amount of 15 kilograms. Congratulations to myself. As good as the process has been, I've been noticing a trend, which is that even though I keep my same routine, same diet as before, my weight loss keeps decreasing. And I didn't understand why. 48 days ago, I made a whole data analysis on my diet and my exercise to see what kind of key influence factor can it be. Like, what if I eat some kind of vitamins and it gives me less weight? I don't know. Yeah, so I did that. But it wasn't enough. If you truly understand something, you must be able to predict it. I'm a scientist and I do everything in a data-oriented way. In my weight loss journey, I logged every single day of what food I eat and what exercise I did using MyFitnessPal. And this means that not only did I have the amount of calories I eat, I also have the macronutrients like carbs, like proteins, to the micronutrients like vitamins and salt. In addition to this, I have a very fancy scale called Withings that also measures my body fat percentage, water mass, and lean mass, and everything. So I have a pretty comprehensive data set about my body. And the story now boils down to what kind of data our model needs for training. Because literally at the push of a button, I can export all my data to a readable format. What does our model basically do? It takes in a week's worth of calories, of macros and micros, and also a week worth of exercise, then it outputs just one single number, which is the weight difference between the beginning of the week and the end of the week. I started this journey around 98 days ago. And if we just extract week by week, we would only have about 40 weeks to start with. This is an incredibly low number of data samples, and you need at least more than 50 data samples to begin with any model. Therefore, we use another approach, which is basically a sliding window. Instead of taking week by week, we take week by days. So every day we extract a 7-day frame prior to this. From 98 days, we can extract about 91 weeks. Amazing, right? And yeah, just with that, I turn data from MyFitnessPal and Withings to data I can work with for my model. Regression is probably the oldest trick in the book. And if you're not familiar with this, I would recommend you search online, YouTube, because there's an abundance of material on this topic. But if you're somehow 10-year-old and you want me to recap everything, then basically linear regression is just a special math function. You have an x value, which is the data that you have, and you have a y value, which is the data that you want to have. And linear regression, or regression as a whole, is just basically some way for you to figure out what the relationship between x and y is, and the magical math formula that will turn x to y. And there are a few key regression methods, and there are a lot of ways to use them correctly, based on your use case, of course. The job we're going to do today is figuring out which model is best suited for our data and how to use it. And to any aspiring data engineer, I always suggest this cheat sheet to them in choosing the model for their problem. So let's start with our problem. We have 93 data samples and we're not predicting a category. So of course, we're going to go with regression. And here we have less than 100,000 samples, so of course we're going to go to the other branch. And here comes the fun part. Normally here, I would have to explain on regularization, so you can choose between rich and less so, or I would have to explain about linearity, so you can choose your perfect kernel for a job. But that will be making this video too long, so I'll just have a very short recap. Regularization basically means your model will be less likely to overfit. It does this by limiting the weights of the features so they cannot be dominant over the whole range of features. Rich does this by making the features smaller, but never to zero. And Lasso does this by the same thing, but it does go to zero, so you can eliminate some of the features. ElasticNet is basically a combination of both, and you can control the ratio between the two. We need to introduce nonlinearity to our model, because whatever relationship lies between calories or macros or micros and weight loss is definitely not linear. We can do this by using a different kernel like RBF or introducing polynomial features. In my case, I just use polynomial features because it's easy to understand, fast to work with. And just that, we basically have a rough sketch of our model. In my particular case, I use ElasticNet since it gives me the ability to adjust the ratio between L1 regularization and L2 regularization, basically between rich and lasso. It comes as no surprise that after selecting the model, we'll take it on to training. And even after that, or before, we have to split our training data set into train set and test set so we won't have any bias when we test our data. So basically, to choose the best parameters for a network to train, we'll do a grid search. And yeah, there's a ton of materials on this as well. You can search it online, but basically using a grid search, I find that ElasticNet with an alpha of 0.1 and an L1 ratio of 0.8 works the best. This is pretty explainable. The reason why L1 ratio is that high, because with high L1 ratio, it means that there's more likely that our features will be eliminated, or per se, it used lasso more than rich. On the alpha, the higher the alpha is, the less likely our model will overfit. And as you can see from the learning curve here, our model is overfitting by a lot. And the reason for this is just not our model, but it's also the low number of data samples we have. Maybe by just adding more features, we can close this gap. You have already seen the result at the beginning of the video. On average, I lose about 1 kilogram per week, and this model outputs an average error of 0.4 kilogram. This is relatively high. Some weeks it's good, but for my personal use right now, it's great for motivation and great insight into my own body. Aside from the obvious shortcomings from the data acquisition techniques, we still haven't been able to capture the temporal features inside our model. If you notice, in real life, even following the same routine or the same diet over time, you'll have diminishing results. Our model cannot predict this because it has no awareness on how long have we stick to our diet. And yeah, we need to somehow figure out a way to capture this in our data set. Now that's a task I'll leave to Bing 100 days later when he has more data.